For our project, we disassembled a Kitchen Smith coffee maker. The parts involved were polypropylene injection molded housings, Phillips head screws, compression springs, rubber hoses, and a heating coil with thermal fuses and temperature regulator. The manufacturing processes we are highlighting in this video will be injection molding, hand soldering, casting, extrusions, and brazing. A majority of the parts on the coffee maker were injection molded. There are various witness marks throughout the plastic parts that show where the ejector pins remove the part from the core mold. Ejector pins typically leave marks on the part because they protrude or are sunken in on the core half of the mold. On these parts, you could also find parting lines. These parting lines show where both of the molds met and there was a misalignment, which leaves a small ridge of extra material.
At the base and the main frame of the coffee maker, there's 2 sprues where the injection molding was cut off or twisted.
A possibility for manufacturing the filter housing would be with blow molding. This would be very good because it could handle high production and be very fast. However, blow molding needs constant thickness, and any kind of details in the part with non-uniform thickness will be lost. Another process found was the use of hand soldering. In hand soldering, one component is individually heated until it is ready to have solder applied and join the 2 pieces. A good thing about hand soldering is that it is ideal for unique applications and oddly shaped parts. However, a bad thing is that there is inconsistency and risk of error due to human interaction. A possibility for a different manufacturing technique in hand soldering is reflow soldering, in which there is a mass production made at a rapid rate. Solder paste is applied similar to a stencil. This is ideal for large-scale manufacturing and it is cost-effective, but it is typically more used on circuit boards. The following part we are looking at is the heating coil of the coffee machine. This is composed of 2 separate aluminum parts that were put together. The first part we're looking at is the bottom, which has several witness marks that show it might have been casted. There are no sharp corners. There is a thin visible parting line around. There are slight draft angles, and there are ejector pin markings that show it was removed from a mold. The top part of the coil is a hollow aluminum tube. We believe this to have been made with an extrusion process. The reason being, it has uniform thickness and geometry. There are no visible separation marks, and it is cut to length and has machined ends.